Okay, so hi, I'm Ayush, and today we are going to discuss search in rotated sorted array 2. So this question is very similar to rotated sorted array 1. If you're watching this video and haven't solved the rotated sorted array 1 or haven't watched my previous video, then just leave and watch the previous video first and then come back here. So the only difference in this problem from previous problem is that we like the problem basically states that we have a rotated sorted array, right? Like this is a rotated sorted array, and we have to find our target. We have to find whether target exists in this array or not. So the only twist here in this problem is that it does not necessarily have distinct values. The previous problem had distinct values, but in this problem we do not have distinct values. The values can be repeated, as you can see, like there are two zeros here. So yeah, and the code you see here is from my previous video itself, the previous code for my search in rotated sorted array 1, in which we did not deal with like duplicates, right? The all elements were distinct. So what if I just run this code? I just changed one thing. I returned true here instead of returning the index itself, and if I did not find the target, then I'll just return false. This is the same code. What if I run it? Okay, this is getting accepted, but let's add one more case here, like 3 comma 1 comma 3 comma 3 comma 3, and my target is 1. Now what if I run this? So as you can see, this gives me a wrong answer despite being the same code. Of course, this is a different problem, so code changes. Why is my code failing here? Let's see. So we the similar example is here. If my low is this, my high is this, and my mid is this, right? Can I just look at my low, mid, and high? Low and mid. Let's talk about this half first, right? Can I just look at my low and my mid to judge is this sorted half or not? I just cannot tell, right? My low and mid are just equal, so I don't know is this half sorted or not. Actually, if you look at this half carefully, it is not sorted. Like 3 is greater than 1, and then this is happening, right? It is not sorted. The actual sorted half is this, but our code does not know. So how can we fix it? Because like you cannot just tell by looking at the low, mid, and high pointers which half is sorted. Low and mid are equal, and mid and high are also equal. So you have no idea whether this half is sorted or not. So the previous code, the previous question code would not work here. The previous approach would not work here. The worst case of this approach won't be login. You cannot just apply binary search, because the whole crux of the previous problem was you were able to deduce one half was sorted, and you were able to check whether the target lies in that half or not. So to like overcome this, there's only one very feasible solution, is that we trim down our search space. That is what we do is, instead, now my low, mid, and high have equal values. Like nums of low is equal to 3, nums of mid is equal to 3, and nums of high is also equal to 3. So I have no idea which half is sorted. Like this was my previous pseudocode, right? So I won't know which half is sorted. I cannot guarantee that this half is sorted. As you can see, because of duplicates, my algo thinks that this is sorted half, but in reality this is not. So if my nums of low, nums of mid, and nums of high are equal, then that means this half is, I cannot tell anything like it is sorted or not. I just have to trim down my search space. To trim down my search space, I would do a low plus plus and a high minus minus until I have three distinct elements. I don't have equal elements at low, mid, and high. So I'll trim down. I will move my low to be low. I'll do a low plus plus. Low would be here, and my high would be high minus minus. My high would be here. So now, as you can see, my mid would be basically now here, right? My no now my low, I can now judge which part is sorted. Like now my nums of low and my nums of mid are distinct, are not equal to or these three are not equal, so I can judge which half is sorted or not. So I can see that this half is sorted, like this is great, low sums of low is greater than mid, so this half is sorted. And I'll check my target. Let's say target was 1. I would be able to check 1 then, right? So the same code works here, same code works, same approach works. But if you have no idea which half is sorted, you won't be able to apply that approach. To apply which, if you don't know what approach I'm talking about, just watch the previous video again, I'm telling you. So you just have to add one thing in that code. Let's go back to, so just have to add that one check, which is if my nums of low is equal to nums of mid, and then my nums of mid is equal to nums of high. So this check basically means that we have no idea of telling which half is sorted, thus we cannot eliminate any half, and we trim down the search space. If I just add this one check, and to trim down the search space, I'll do a low plus plus and high minus minus, right? And with this just one check, I would be able to run my code. This would run fine. Okay, what error do we have? Okay, got the issue. So after executing this, we have to continue. Like after trimming down our search space, I need to find mid again, and I'll have to repeat the loop. This is one iteration. So if I continue, then I'll find mid again, then I'll continue. So now this should work. Yeah, this got accepted. Let's submit it. Let's check. Yeah, it is accepted. So yeah, that's it. Like this was one very important condition which you should know, like why we were not able to apply binary search. So the only downside of this approach is that we would have to like do low plus plus and high minus multiple number of times, in worst case of n times. So this would be in worst case linear complexity. But as we can see in this question, it is given that you must decrease the overall operational steps as much as possible. So we tried to decrease, we applied binary search, but we are handling this case separately. So average complexity might be log n, but in worst case this also goes to O of n, but interviewer would be satisfied with this approach. So yeah, that's it. Bye bye.